Hi everyone, welcome to Lisa Video Lessons. In this video, I will review linear scatter plots, correlation coefficients, linear regression equations, and all this so that we can make predictions using linear regression equations. Enjoy your lesson.
There are different kinds of relationships between x and y. In our course, we are focusing on linear relationships only. The goal of this whole lesson is to find the equation of the line that is closest to all the data points so that we can use that equation to make predictions. In the top graph, you can see a strong positive linear relationship. And in the bottom graph, you can see a very strong negative linear relationship. The closer the data points are to the regression line, the stronger the relationship is between x and y. The correlation coefficient R measures the strength and direction of a linear relationship between x and y. We would expect a strong positive linear relationship between the hours studied for a test and the test results. The more hours you study, the higher your test results will be. We would also expect a very strong negative linear relationship between the number of absences and your total grade. As your absences increases, your total grade decreases. When looking at scatter plots, we can visually see the strength and the direction between two variables. The correlation coefficient R tells us the same information. Here you can see examples of scatter plots and their respective correlation coefficient. The closer the correlation coefficient is to either -1 or 1, the stronger the relationship is between x and y. The closer the correlation coefficient is to 0, the weaker the relationship is. 0 actually means there is no association or no correlation between x and y. So the correlation coefficient R ranges between -1 and 1. We will only make predictions if R is strong or very strong. So for values between the absolute value of 0.60 all the way to the absolute value of 1. So both on the positive and negative side of the correlation. If the correlation coefficient measures between 0 and the absolute value of 0.59, the relationship is not strong, and so the predictions would be meaningless. Here you can see several lines drawn on the scatter plot near the data points. We must find the equation of the line of best fit. Best fit means the sum of the squares of the vertical distances from each point to the line is at a minimum. Wait, what? In simple words now, the line of best fit means the line that is closest to the data points. The reason one needs to find a line of best fit is that the values of y will be predicted from the values of x using the equation of the line of best fit. Now, how do we find the line of best fit? So remember from algebra, we learned y is equal to mx plus b, m being the slope and b being the y-intercept. Well, in statistics, we write that equation a bit different. Y is equal to a plus bx. B being the slope, the number in front of x is always the slope, and then a being the y-intercept. So when we have our regression equation and we know the correlation coefficient is strong or very strong, then and only then we can make predictions using the regression equation. The predicted values are on the regression line, and as you can see, the actual observed data are not always on the regression line. Okay, let's do an example. So I've recorded the number of absences and the final grade of 7 randomly selected students in my class. From the scatter plot, I see a negative linear relationship. So therefore, the correlation coefficient will be negative. R is found to be -0.944, which indicates a very strong negative linear relationship between the number of absences and final grade. Because R is significant, only because R is significant, we will find the regression equation so we can make predictions. When you find the regression equation, you will see that the slope will be negative as well because the equation decreases from left to right. We will use the regression equation to predict the final grade for a student who missed 4 classes. In the regression equation, we will substitute 4 instead of x. Now use your calculator to find the answer. So when a student misses 4 classes, the student's final grade is predicted to be about 88.
I hope this video was helpful. Thank you for watching and see you next time. Bye.